the fact that the speed of light is frequency of the wave times its wavelength, such that F becomes the speed of light, which is c over. So making that substitution in the formula, changing E equals to HF, we'll have that H times c lambda. So the energy difference, which is this, is En minus E naught, will also give us HFN. And this HFN is, the Fn tells us the frequency of the electron in that particular state. All right. So let's see some numerical problems. So an electron jumps from one energy level to another. An electron jumps from one energy level to another in an atom radiating 4.5 times 10 to the power minus 19 joules of energy. If Planck's constant is 6 times 6.6 times 10 to the power minus 34 joules, what is the wavelength of the radiation? Take velocity of light c equals to 3 times 10 to the power of 8. So how do we solve this? Let's solve this. So the first thing, let's bring out our parameters. An electron jumps from one energy level to another in an atom radiating 4.5 times 10 to the power of 19 joules. So what is that 4.5 times 10 to the power of minus 19 joules? Remember, you have to bring out your parameter well. Read the first sentence very well and understand it. An electron jumps from one energy level to another in an atom radiating 4.5 times 10 to the power minus 19. It means the 4.5 times 10 to the power minus 19 is the energy difference. So the energy difference is this. Minus 19 joules. Good. So having known that, we know that the energy difference, we've been given a Planck constant to be 6.6 times 10 to the power minus 34, and c, which is the speed of light, is 3.0 times 10 to the power of 8 meter per second. This is joules second. So we can make substitution into the formula for energy difference. So energy difference is given as hc over lambda. So we have to calculate the wavelength of the radiation. So making wavelength the subject formula, we have that wavelength is given as hc over change the energy difference. So our h is 6.6 times 10 to the power minus 34 times our c is 3.0 times 10 to the power of 8, and then the energy difference is given as 4.5 times 10 to the power of minus 19 joules. So punching a calculator, we can get the value for our wavelength. Our wavelength will definitely be 4.4 times 10 to the power of minus 17 meters. So that has been resolved. So bring out your parameter, make substitutions correctly into